And you know, I cannot underscore this enough. This is a weird out-of-body experience if you are used to building Lustre clusters inside, you know, regular data centers out of hardware.
Well, you can't do it on the fly. I mean, it's a long process. You need to procure it and physically build out the racks, the data center.
And migrate your data to it and then decommission the old one.
So it's not simple, very painful.
You just can't do this. This is just not possible.
FSx for Lustre is AWS's fully managed offering of the open source Lustre file system. So we all know that, right? But in situations where you need your storage to keep up with your compute, it's designed for the fastest of the fastest computers in the world. And it does this by offering sub-millisecond latencies, up to hundreds of gigabytes per second of throughput, and up to millions of IOPS. Now that's pretty cool. So what can be better, right? Well, there is more, including the scalable metadata. And it's had some recent enhancements, but better than listening to me talk about it, let's watch some demos on how easy it is to deploy, how flexible it is to adjust capacity and performance, including the scalable metadata.
So when you create a new file system, if you want to keep just super simple, just can answer two basic questions or three basic questions, let's say. You select the type of disk that you want, if it's a solid drive or if it's a hard drive. And that's a trade-off between performance and cost. Let's say that you don't the IOPS that SSD will deliver, but you can deal with the hard drive latency and performance. The second thing that you need to answer is how fast you want that, or how much throughput you need on that file system, right? So FSx for Lustre will allow you to define which throughput you want by terabyte allocated. When you size your file system, the more capacity, of course, the more nodes, more disks, and consequently more IOPS and more throughput you have available, right? So this is, you can go from 125 megabytes per second per terabyte, and you can go all the way up to 1,000. When you define the capacity, for example, here I'm defining the smaller possible capacity on a file system with Lustre, which is 1.2 terabytes. You see here automatically the total throughput capacity for this file system. And as you grow here, you see reflecting on the total throughput capacity. And remember, this is disk throughput. This is not overall throughput. Why I'm saying that? Because you have network, you have cache mechanism in the middle, you have compression, you have several things that can make this throughput even bigger than we see here. So this is just when the data gets to the disk. Those are the three things that I said that you need to do to create a file system. Simple like that, you can just go next and create. You have additional knobs that our customers like to use when they need to fine-tune their file system for specific workloads. For example, one of the things that Mitch mentioned, our recent launch of scalable metadata, right? So before that feature that we launched a few weeks ago, we had just one metadata server. So think about file opens, stats, get attributes. Now we are able to scale this up or scale out actually across multiple nodes. And then users can rely on our suggestions. So if you are sizing the file system here, we automatically define the size, or the user can define themselves according to their requirements. So if they go to CloudWatch and say, wow, I'm using a lot of metadata operations here, I'm doing like 30,000 IOPS on just on metadata operation, I need to increase my capacity. So they just can go here and increase that capacity up to the limit of 192,000 IOPS per file system. This is the total IOPS for the entire file system, just for metadata. I'm not talking about IOPS on the performance, on the data itself.
Got it. So let me just say, 192,000 IOPS for metadata IO is pretty crazy, right?
Yeah, it's if you think about the size that you can go with a file system like Lustre that can go beyond petabytes of data, it sometimes makes sense to have that much IOPS on the metadata.
This is going to be a very, for the kinds of customers that we frequently deal with, this is going to be really useful to, for example, genomics customers. They do have hundreds of thousands of tiny little files that need to be assembled into larger genome assemblies. So, this is actually going to be a really important feature. Does this number scale at all with the capacity? So does the ceiling here, the 192,000 IOPS, does that go up depending on the capacity of the file system or any other parameters?
Yes, that's correct. You can see here, I went from 3 to 6,000 when I add additional capacity. So yes, as you increase the capacity of your file system here, you will see more IOPS automatically being assigned here on the metadata configuration. But you can go beyond that number. If you need more, you can just go here and add more. And what's happening here on the back end, we are adding additional servers to fulfill that requirement, to fulfill that additional IOPS. And of course, there is a cost associated to that as well. So if you use the automatic configuration, you are not charged. If you go beyond the automatic, then you are charged by the additional resource that you. And then finally, the data compression, right? That's optional. By default is known, but you have the option to activate LZ4 compression to your data. That's if your data is compressible. So you have to understand the type of data that you have in place. If it's compressed already, you're not taking big advantage of that. But if it's compressible, enabling compression, you are able to even increase the throughput, because we are doing the compression between the memory and the disk. So if you have more capacity available for the same pipe, then you have more throughput, right? So that's the idea behind that.
And just for the skeptics out there that are watching this in the HPC community who are saying, no, hang on a minute, compression is the enemy of performance. Yeah. They're actually wrong in this particular case, because what we're using here for all of our OST servers, the servers that are actually fronting the Lustre file storage nodes, we're using Graviton-based instances there. And those Gravitons are actually pretty steamy little CPUs, and they're doing all of the compression real time. And they're also keeping the file system and all of the infrastructure pretty cheap. So the compression is pretty much for free, because these CPUs were going to be there anyway carrying the data. Now they're able to do the compression real time. And in fact, now the compression is no longer the enemy of performance. In fact, if you've got compressible data, like say genomic data, compression is actually now pretty much going to be part of the performance tuning for you.
You have a screen just to check everything that you just did, things that you can change later, things that you cannot change later, and create file system. It takes around 20 to 30 minutes to create a file system, depending on the size, depending on the region, but it's just a few minutes. As you just saw, in a few minutes, you can have a complex cluster of storage created with a few clicks. Same thing also is true when you need to adjust that file system.
And if you were doing this on-prem, it would be a case of bring in the forklifts, we're upgrading Lustre. And it's another 6 months before it'll be ready.
It's a lot of work, and since it's a repetitive test, very likely to get trouble with errors or mistakes or issues, hardware issues, software issues. So yes, how we do that with FSx for Lustre. So this is a file system, right, that I have here, and I can update the size of this file system. So as you can see here, this is the file system ID. This is the current storage capacity of my file system. And then I can increase that capacity. So let's, for example, say that I need this to be 10 times larger. I will update my file system to 12 terabytes and update. And that's it. That's all it takes to update a file system. And for example, what about throughput? If I need to increase the throughput, I can do that even in parallel here. I can add more performance to my file system, updating the throughput to the next level, or decreasing that to the lowest level. So I have the option to increase and decrease the throughput as needed on my file system. You also have the option on the fly to increase the metadata operations available for your file system. So in this case here, for the file system just created, we have the default, the automatic define of 12,000 IOPS. If you need more than that, you just go here and update, and then you can select the user provisioning and select how much IOPS you need.
And again, this is just magic.
Yes.
It isn't, of course, magic. It's close to magic, but it's not quite magic. So you may have to wait some time for the rebalancing to occur, but still the rebalancing is going to occur over a matter of hours, not 6 months.
Exactly.
If you enjoyed this tech short, please give us a like and consider subscribing to the channel. If there's a topic you want us to focus on, reach out to us at askhpc@amazon.com. We want to make it easier for scientists and engineers to solve the world's hardest problems. We think the cloud can help by giving them access to powerful tools of any shape and size whenever they need them. And that's where you come in. Let us know what you need. We'll see you next time.